There's a lot of moving parts. There's a lot of stuff that's happening. And when something goes wrong, you have to be able to really fast understand what went wrong and why in order to fix it. Because it's easy to think about deployments and pods and clusters and all that. But at the end of the day, there are real world customers who are using our application. And you might be a Fortune 500 company, which has this service that has to be up. And when that goes down, all the buzzwords, all the different stuff in the world doesn't matter. What matters is that you get that back up and running as fast as possible and you serve your customers, that your business does what it has to do. And the trouble is that both of those, both the first part where you realize something went wrong and the part where you realize why it went wrong, have become harder and harder over time as our systems get more and more complex. So in terms of problem identification, it's very useful sometimes to look at that external perspective where people use SLOs, service level objectives, and using that and like related stuff, you can tell when something is wrong. But then once you know something is wrong, to troubleshoot that and to really observe that and to understand why it's happening, then sometimes you need a different set of tools, like that you drill down and understand why stuff is happening. Ultimately, the context is really important. So I'm like a huge believer in that. Also in the actions I take in my personal life and doing a startup around that. But the problem is when something goes wrong, the immediate piece of data that you're looking at is often not sufficient to understand why it went wrong. And there, the contextualization, taking something that went wrong and adding on the context for why it went wrong is really important. If again, like you want to get your business back up and running, don't start with necessarily the pod, start with a high level deployment. Like, okay, I have a deployment, I have a service. Is that functioning? Is that healthy? Is this microservice behaving the way it should behave? And then when you say infra, it could be like, there's almost two levels of infra. So the first level of infra is, okay, I have a problem with the pod. Now I just want to look at the node that's running on, or Kubernetes related stuff, or I'm looking at the deployment. I want to zoom into the pod. I want to zoom in now to the node that's running on. I want to understand what happened there. Sometimes you have to do that. It's almost an inevitable part of the way systems are built today. I think there's a challenge with a lot of the traditional tools, which is that they work fundamentally based on tags and correlations. And I'll give an example to make that really concrete. So I have a pod that's running. That pod is part of a deployment, and that pod is running on some nodes, and it emits a log line. So that log line now shows up in CloudWatch. And if everything was set up properly, then that log line has like a few tags on it. And you can now take those tags and you can use those tags to like get back to the pod or to get back to the deployment. And maybe you don't know data about the node, but like once you get to the pod and you can like try and again correlate stuff with the node, that's a process that a human can do. But you as a human have to do that contextualization manually. The problem is that if you look at like from CloudWatch's perspective, CloudWatch doesn't know anything about Kubernetes. CloudWatch doesn't know anything about pods, anything about deployments, anything about nodes. CloudWatch has a log line, and that log line has a bunch of tags. And those tags happen to have like pod equals XYZ. There's the traditional Linux approach, and the traditional Linux approach is one tool for each job. And then the other approach is like the Windows approach. We're going to build one thing, it'll do everything for you, it'll do everything for everyone. And you can go both ways. You can take, for some stuff, you can take one tool and one stop. And for some other stuff, for some other companies choose, take a bunch of different vendors that work well together. It has to be like Linux, like the traditional Linux philosophy with Unix, where you can actually connect those tools in a coherent way. But they're okay taking Prometheus for metrics, but taking, let's say, Elasticsearch for logs. But I think the challenge, this connects to what we said about contextualization, challenge is when you have all these different tools, how do you take the increasingly complex, increasingly large number of stuff that you have to support and still as one person have all the knowledge inside your head for how to handle it? And that's a real challenge. I think that's part of where technologies like runbook automation come into play, and that contextualization and the ability to deliver as a software experience the knowledge that you would look up on Stack Overflow. When we speak about that contextualization, like something went wrong, how can we go and gather the context, maybe run like the exact commands you would run if you investigate this as a person and looked at Stack Overflow, and then translate that into insight for you that you as a human can consume that says, oh, what went wrong over here is XYZ. I just need to click this button to fix it. And that's kind of the concept of runbook automation, or this contextualization that's based on the exact scenario that went wrong. So the two areas that we really see the most customers getting the most benefit from is one, when they have multi-cluster environments. Some of the traditional tools are good if you have like one cluster or a small number of clusters. Then when you're really acting at scale, they just weren't built for that. So that's one niche. But those multi-cluster environments are somewhere that's very painful with a lot of the traditional tools. And think about it, like you have 3 different Prometheus instances or 500 Prometheus instances, each one in a different cluster. Then you have to be able to pull together all that data into the right place. So that's hard to do sometimes with traditional tools. So that's one area where we see a lot of value. And then the second is around the ability to really get you fast to the root cause and to get you to the why and to get you to the fix. What we do and what we're really good at doing is making sure that when you get that alert in PagerDuty or in Ops Genie or in Slack or whatever system you choose, because like we try and meet you wherever you are, we're not trying to change your behavior. But when you get that message there, that it has the context, that it's done that contextualization, and then you know what the next step is and it's really actionable. So So that's like the horizontal benefit that we're trying to provide. And then that specific thing becomes like especially good if it's in a multi-cluster environment. Both deployment models, like in the number of clusters you have and all of that, are valid architectural choices. And there are real good reasons why you would choose to go with one way or another. Hopefully that doesn't impact your choice of observability build, tools just based on building that like on cookie cutter build and it doesn't take your needs into account. I'm what you would call a Kubernetes maximalist. I believe that Kubernetes, for various reasons, that Kubernetes or something very similar to Kubernetes is the future. I think the choice that you have to make is, am I building applications that run on the distributed operating system known as Kubernetes? Or am I building applications that run without something else? If you go back to like the early days of Windows, like you have to decide, am I writing something that runs on a microprocessor, application that runs on a microprocessor without an operating system? Or am I writing an application that will run on Windows or Unix or whatever, and then I can run it on any hardware? The hardware here is either on-prem, or the hardware is like AWS, or the hardware is GKE. The hardware might be a different Kubernetes data center in different places. If you're targeting the operating system that's Kubernetes, the distributed operating system that's Kubernetes, then you have a lot more flexibility. If you have an application, it's running in production, and you're a year away from even having customers accessing that application in production. Right now, it's just internal dev teams. And if something crashes and goes down, there's no impact whatsoever. Then yeah, I wouldn't invest in building out observability for that. I would invest in the developer experience. How fast can developers like do code changes? Or how fast are they working? What's their iteration cycle like? I would look at tools there like Octeto, for example. I would try and look at different stuff in that space. I wouldn't really focus too hard on building out the perfect observability system for something that's not even running in production yet. So it doesn't always make sense. Speaking from my hat as a co-founder, like everyone speaks about the MVP, the minimal viable product. But what people sometimes forget is the V. It has to be viable. And it has to be viable from a security perspective too. Like if I'm doing an MVP and my MVP is exposing credit card information, that's not an MVP. It's not viable from a security perspective. When you take viability into account, when you build that MVP out, you have to make sure it's viable. Now, what viability means differs depending on the stage. So at some stages, it's viable without having that observability. If it's processing no real production data yet, and there's no customer data on there, then like maybe in terms of security, there's like a little more leeway in terms of viability. If no enterprises are using it, then you probably don't need an OAuth integration, but it really depends on where you're at. It does have to be viable from a security perspective and from an observability perspective as well. We have companies that don't want to send any data to the SaaS platform, but they want to use the features of the SaaS platform. But you have to understand there's a trade-off in terms of engineering resources. Stage startups don't care about security. Well, if you don't care about security, you're not going to have Fortune 500 companies. You're not going to have Fortune 500 customers. So you have a trade-off to make. Do you want to have, at the current stage, those Fortune 500 companies? And is it realistic for you, given your current resources, to support them or not? You have to make hard decisions there. And you don't always know whether that decision is right until like 6 months later. So that's a hard decision to make as a product leader. And like when you're planning out your roadmap, there's like a fundamental trade-off when you're building these products. Like you have to understand the end user will take security into account when evaluating you. And you have to decide what security requirements you're going to satisfy. Understand that it's a trade-off between engineering resources and not getting to implement other features and being able to provide the level of security that these large companies want.